Hi! Did I just hear that you have some problem in arithmetic progression? Well, it is pretty simple. In it, the next term is got by adding a specific number to the last term. As simple as that. So here, in this lecture, we will be looking up what an arithmetic progression is, how we can find out the nth term, which is also known as the last term. Further, we will also be looking up what a geometric progression is. Wait, we'll look it up in a little while from now. Further, we will also be looking up a sum which actually relates both of these, and it is an important sum, and I can tell you that. So all of this is for children who have arithmetic progression as well as geometric progression in the middle years program of IB board, or say IGCSE board, or say in class 11th of say CBSE board, or say class 10th of ICSE board. So all of these children are going to benefit by this. And now all of your concepts of finding out the nth term of both of these progressions, that is the arithmetic and the geometric progression, are going to be all clear. So are you all set? Are you all seated in a space where there is no disturbance, no electronic gadgets, nobody around you, relatives, friends, acquaintances, parents? So make sure that you're seated alone on a table and chair so that you can concentrate and understand the best. At this time, please don't pick up a pen or paper and just focus to all that I'm telling you. So children, when we talk about arithmetic progression, like I told you, if you are to get the next term, then whatever is the last term, you are just to add a number to it. For that matter, we will have an example here. Let's say now that we have the first term to be 1, right? Now to 1, if say you add 4, right, you'll get the next term. Now to add 4 again to this, you will get the next term. So every term is got by adding 4 to the last term. So as such, the next is going to be 1 plus 4 plus 4, which at the moment I am not simplifying, plus 4. So this is the special characteristic. And here children, the interesting thing is this, that if you talk about this, this is the first term, this is the second term, this is the third term, and this is the fourth term, right? So can you tell me what is the interesting thing that I am planning to tell you? Well, no. Well, I'll tell you. If you see each of these terms, then there is something special which is happening. Obviously, that constant 4 is getting added. But how we represent it is actually what is something special. That is, if you talk about the difference of any two consecutive terms, you will always be getting a constant. Like in this case, you'll be getting that to be equal to 4. Now, this constant, children, is known as the common difference, right? Common difference. Now you have a first term, right, like this, like 1. So similarly, generally speaking, we say that the first term is say some small a. To that, a constant d is added to get the second term, and then again the constant d is added to the second term to get the third term, and so on. So the thing which is special, which I want to tell you people, is this, that you get to see that as is the number of term. Like here we talk about the fourth term, so you will find that there is one less number of common difference, that is here, as the common difference is 4. So to 1, which is the first term, 1 less than the nth term, that is the fourth term, we are adding the common difference. So this is what is going to help us in finding out the nth term. Now children, the formula for the nth term goes something like this. That is, we now have Tn, which is also the last term, and that becomes equal to a, which is the first term, plus n minus 1 times of the common difference, which is small d, right? So children, this is the formula that you require to learn, right? And for that matter, I will just put this in a box so that you can remember this. Moreover, this concept that I told you earlier is also an important concept, and you also require to earmark this. That is the basic characteristic of an arithmetic progression is this, that the difference of any two consecutive terms where first you write the later term and from that you subtract the earlier term will always give you the common difference. So this is all about finding out the nth term of an arithmetic progression. Isn't it easy? Well, to make it more easy, I will quickly revise all of this. Here at this time we are talking about an arithmetic progression, right? For that matter, remember that whenever there is a comma which separates the different terms, then it is known as an arithmetic progression. But in place of it, if suppose we have plus sign, then it is no more a progression, but it becomes a series, right? So then we have 1 plus 1 plus 4 plus 1 plus 4 plus 4 and so on. This then will become a arithmetic series. Now children, here as one fixed number is added to the last term to get the next term, here the basic characteristic is that the difference of any two consecutive terms like t2 minus t1, t3 minus t2, for that matter you can even have t13 minus t12, and that will always give you the common difference small d. And this is what I have written here and put this in a box because this is important, right? So you people also can write it. Now after this we talk about the nth term of the arithmetic progression, which is given by Tn is equal to L, as it is also known as the last term will be equal to the first term a plus n minus 1 times of the common difference. N is the number of terms that you're interested in, d is the common difference, and a is the first term. Now children, next we come over to the geometric progression. Now if we are interested in talking about the geometric progression, children, then in place of addition you just have to multiply. So that is the only difference. So here we are going to talk about geometric progression, right? And we are celebrating this with a special color, which as you can see is the rainbow color, right? So here we are talking about a geometric progression. Now one thing which I forgot to tell you people about an arithmetic progression is you need not always tell such a big word, rather a phrase, arithmetic progression. You can also just say AP and that'll work, right? So this is the abbreviation AP, and that stands for arithmetic progression. Similarly, if you talk about a geometric progression, you can just do by saying GP. Okay, so this I'm sure has made your work a lot simple. You'll have to write little. Okay, now children, like I told you, if suppose you have a term, let's say a, right, and to that a, if suppose you now in place of addition multiply a number, and normally it is written by convention to be r, right? So ar will become the next term. Now after this, again, if we are interested in doing this, then again we require to multiply this with the same constant, that is r, right? So as such we will get the next term. Now to get the next term, I'm sure you all will be able to tell me that this is going to be ar, which was multiplied with r and is again going to be multiplied by r, right? Now children, to simplify this, we can write this. Now remember, this is not a geometric progression, but rather this is a geometric series. So unless and until we talk about finding out the sum, so let's just write a comma, right? And when we require to find out the sum, then we can replace this comma with a plus sign. Okay, now in the next term, rather in the next step, what we can do is we can write this to be a, and then we have ar, and then we have ar square, and then we have ar cube, and all of that children continues up to the last term, which is ar raised to the power n minus 1. Now here children, I'm sure you're able to note this, that if say we talk about the terms, a is the first term, ar is the second term, ar square is the third term, ar cube is the fourth term. So as many is the nth term, like here if we talk about this fourth term, we have nth term, that means the number of term that we are interested in is 4. And as you see, the power of r is just one less, right? So similarly, if you talk about the third term, you find that the power of r is just 1 less than 3, the nth term, that is r square. And thus, if you talk about the nth term, again, we should have just one number less in the power than the nth term. So since this is the nth term, thus we have ar raised to the power n minus 1. And children, this becomes the formula for finding out the nth term, which again is also known as the last term, as it is the term which will come last in the sequence, right? So that is ar raised to the power n minus 1. And since this is important, again, I will put this in a box so that you can remember this. Okay, so here now, to make this a little important, I'm putting this in a box. So children, you require to remember that this is an important concept. Now after this, we will now be discussing that special characteristic which a geometric progression has. That is, if say you talk about the ratio of two consecutive terms, that is, if t2 is divided by t1, it is further going to become equal to t3, which is divided by t2, right? That means if we find out the ratio of the consecutive terms where we put the term which has come later in the numerator and that term which has come earlier in the denominator, then we will get this ratio always to be equal to the common ratio r, right? So this is the special characteristic, and as this is again important, so I will put this in a box, right, so that you can write this in notes and also learn this up. Okay, so children, you can take a small pause, learn these formulae, and then move ahead. So all of these concepts about geometric progression that we discussed is what I'm going to quickly discuss. Now, geometric progression can be abbreviated to be GP, just that much. So that'll save a lot of your time, I'm sure. Now, if you talk about a geometric progression, here, if we have a term, then that term or that number, if it is multiplied by a constant or a number, right, then you get the second term. Now again, to the second term, if you multiply the same constant, right, then you get the third term, and that goes on. So like a number was added to the last term to get the next term in an AP, here in place of adding, we just multiply the last term with a number to get to the next term, right? Okay, so as such, there is the characteristic that if you divide the later term by the just earlier term, that is two consecutive terms where the later term comes in the numerator and the earlier term comes in the denominator, you will get this ratio to be equal to the common ratio, right? So thus t2 upon t1 will become equal to t3 upon t2. Obviously that will also be equal to t30 divided by t29, right? So this is always true. Now from this we've got this, that the nth term or the last term is given by a multiplied with the common ratio small r raised to the power n minus 1. Now here children, you require to remember that a is not raised to the power n minus 1, but it is only r which is raised to the power n minus 1, right? So that's why what I'll do is I'll rather put this in a bracket so that you don't make a mistake. Okay, after this a lot of concepts, right? I'm sure now you're going to pause and write them and quickly learn it up, and after that we will be proceeding with a sum. So the sum which I want you people to try initially is this. So what you have to do is, like you're already seated at a secluded place so that there is no disturbance caused by anybody, your relatives, your friends, and any electronic gadgets like PlayStations, laptop, TV, mobile, etc. right? And sitting on a table and chair, that's the best way that you can study mathematics, right? So just focus on all the concepts that we discussed and just try cracking the sum, and I believe that you can. Always what you require to do is just start, and when you just start, you will find that the wheel will start rolling, things will start happening. Okay, just give it a try. I'm just giving you 10 seconds. I'm sure you want more time. For that, you can pause the lecture for a little while and then try it out. Okay, right. So I think you're trying out, right? Yeah, please try out. So likewise, I will keep helping you people, and whatever problems you have, there is a form which you will get in my profile. You can just fill up that form and tell me what your problem is, and then I'll come to you probably live and help you out with some resource so that you are helped. This is what I want to do to a million children. So anybody who has a difficulty in mathematics, do tell me, do let me know, and do let those people know so that they can contact me and ask for help, and I'll always be ready to help anybody out in mathematics, right? So this is the mission of my life, to be able to help 1 million children and also to be able to make mathematics teachers. So you learn mathematics so well that you teach the next generation mathematics is what my dream is. Well, now let's continue with the sum. Here we've been given that there are the first, fifth and the 13th terms of an AP which are such that they are the first 3 terms of a GP, right? So this data is what first we will write. So we have the first term T1, then we have the 5th term, and then we have the 13th term, right, which are that of an AP, and they are actually the first term, the second term and the third term. That is, they are the 3 consecutive terms of a GP. Now this is the fact which has been given to us by the first statement. Now after that, we've been told that then find the common difference, right? We have to find the common difference and the common ratio if the first term is 12. So we've been given another data that is the first term A, which we can keep in place of T1 is actually 12, right? So this is the data which we've been given, and we have to find out the common difference, which is small d, and we also have to find out the common ratio, which is small r. So here, children, we'll start off by talking about what the nth term of a arithmetic progression is. For that matter, quickly be reminded that if we talk about Tn, then that's equal to a plus n minus 1 times of d, right? This was the formula. So we'll be using this formula to find out the 5th term and the 13th term of the AP. As such, here we will have T5, which will become equal to a, which has been given to us to be 12, plus, as it is the 5th term, so 5 minus 1 times, or we don't know what the common difference is, we just write it to be d. So in the next step, we can write this 5th term to be 12 plus 4d, right? So this thus is one of the equations that we have, so we can mark this to be equation number 1. Now after this, children, we will be talking about the 13th term. So in a similar way, we will say that the 13th term will become equal to 12, which is the first term, plus we have 13 minus 1 times of whatever the common difference d is. So for the children, this calculates to 12 plus 12d, right? And this, children, can be written as the second equation. So now here we have 2 equations, and as we know that these terms are also the terms of a GP, the first, second and the third terms. Thus, if you talk about the ratio of the consecutive terms of a GP, you should get the common ratio, right? So this is the property that we will write, that is, since we have T2 when it is divided by T1 will become equal to T3 when it is divided by T2. So as such, here this gives you the common ratio small r. So in this, if you substitute the values, we have T2, which is actually our fifth term of the AP, which we've calculated to be 12 plus 4D, right? Now we divide it by T1, that is the first term which we've been given to be 12, right? And further then, on the right hand side, we have to write T3 of the geometry progression, which is the 13th term of the AP. As such, it is 12 plus 12D, right? And it is divided by T2, and T2 is actually the fifth term of the AP, which is 12 plus 4D, right? Now children, here we get to see that there are certain things that we can do which will actually help us in simplifying, right? So we have the third term, which is 12 plus 12D, right? And it is divided by the second term, which is 12 plus 4D, right? And here you have the second term, which is 12 plus 4D, which is divided by the first term, that is 12. So we get to see here that if we cross multiply, right, we can do some simplification. But before that, if we take common, then that will be a better idea. So here in the numerator, if we take 4 to be common outside, we know that it is going to become 3 plus D, right? And in the denominator, you have 12, and on the right hand side, you can take 12 to be common outside, then we'll have 1 plus D inside, and in the denominator, children, you have again 4, which can be taken common outside, and then you have 3 plus D that can be written inside. Now for the next, what you do is we will be simplifying this. So 4 will cancel 12 3 times, and then further we will cancel 4 with 12 3 times, right? So as such, now we have 3 plus D whole square by cross multiplying, and further on the other side we have 3 3's, of which becomes 9 times of 1 plus D, right? This is all that is left. Now next, what we do is we just expand, bring everything to the left hand side, make D the subject of the equation, and find it out. So on expanding, since you know that a plus b whole square is given by a square plus b square plus 2ab, as such this becomes equal to 3 square plus d square plus 2 times of 3 times of d, right? And that further is equal to 9 plus 9d, right? Next, now we have 9, which is 3 square plus d square plus you have 6d, right, which further is equal to 9 plus 9d, right? Next, now children, what you do is you can see that we have 9 on both the sides. As such, we can cancel it off, and then further we also have some d's which can be cancelled off, and as such we will bring everything to the left hand side, and thus we have d square, and we have plus 6d, from which 9d can be subtracted, and all of this is equal to 0. As such, we don't have the constant term. So thus this becomes d square minus 3d, which becomes equal to 0, right? Now out of both of these, we can take d to be common outside, and then we have d minus 3 inside, and their product is equal to 0. Now here, children, we will be applying the zero product rule, right? So what's the zero product rule? Can anybody tell me in class? Yes? Do try. It's a rule that you've been using for long. It is this, that if you have the product of a and b to be equal to 0, right, then you will have either a to be equal to 0, that is one of the terms to be equal to 0, or you will be having b to be equal to 0. Both to be equal to 0 is something which is immaterial. So next, now applying this, we will now have either d to be equal to 0, which is one of the options that we have, or the other is that we have d minus 3 to be equal to 0, right? So when we talk about this d minus 3 to be equal to 0, this can further be written as d to be equal to 3. Now here we have two answers. One, that the common difference is 0. That is something which is not possible, All right, so the other answer is the one that is possible, and thus we will put this in a rectangular box, showing that this is actually one of the solutions that we require to find out. Right, now after we've got the value of D, we can now find out the value of R, as D and R are related, remember. So what is the relation? We have the relation that we have here, this, which actually gives us the common ratio small r, right? So when this is calculated, we can further write this as small r, right? And now children, from any one of these ratios, you can put that to be equal to small r. So let's pick up the first one, which is more simple. So we can write that 3 plus d upon 3, right? So we have 3 plus d divided by 3, that is equal to small r, right? Okay, now from this we will be able to find out the value of r, as we now have the value of d, which is 3. So we now have 3 plus 3, which is divided by 3, and that will give us the value of r. So as such, r will get calculated to 2 times of 3, which is divided by 3, where we find that we can actually cancel off both the 3's, and thus we are left out with the value of r, which is 2. Now since this is another of our answers, so we will put this in a box again, so that the examiner can very easily find this out, right? So this is our second answer. Okay, now children, after this I will just quickly discuss the sum with you people. So in the question, you've been told that the first term, the 5th term, and the 13th term of an AP are such that they are the first 3 terms of a GP. So here we have the first term, the 5th term, and the 13th terms, which are in AP, right? And we have written it, right? So these are 3 terms, right, which are of an AP, right? These are not in AP, but they are the terms which are the terms of an AP, right? Okay, so now children, what we do is, here if we write them in order, they actually form the first, the second, and the third terms of a progression, which is a geometric progression. So as such, the basic characteristic is, if you divide T2 by T1, you should be able to get to R, which is the common ratio, which further is going to become equal to T3 divided by T2, which is the concept that we're going to use. First, we will talk about T5, as this is the 5th term of an AP. So we use the formula for the nth term of an AP, which is Tn is equal to a plus n minus 1 times of d. Now here, when we keep the value T5, that becomes equal to 12, which is the value of a, plus 5 minus 1 times of d, which is the common difference. As such, T5 becomes equal to 12 plus 4d. Now we talk about T13, which is the 13th term of the AP. As such, a plus n minus 1 times of d is going to be applicable, that is 12 plus 13 minus 1 times of d, where 12 is the first term. Next, we have here 12 plus 12d, which is the 13th term. Now we talk about these 3 terms as they are in GP. So dividing the second term by the first term, which are in GP, to be equal to dividing the third term by the second term, which are again in GP, we will be able to get the common ratio, right? So next, now what we do is we actually put the value of these terms. T2 here, children, is what it is, T5, right? So I'll rather write this, that if you talk about T2, then that is your T5 of the AP. And if you talk about T13, that is actually what? That is your T3 of the GP, right? Okay, so now we have our T2, we have our T3, and obviously our T1 is 12, as we've already written it. Now further, we have the ratio to be equal to R. Now we can now write the value of T2 in terms of D, that is 12 plus 4D, and when divided by T1, which is 12, we will have that equal to T3 upon T2. T3 is how much, remember? It is 12 plus 12D, that is divided by T2, which is how much? It is 12 plus 4D. right? Now children, we find that there are certain constants which are common, so we take 4 common from the numerator and we divide it with the 4 that is there in the denominator. So the common 4 getting cancelled, we have 3 plus d, which is divided by 3. Now further here on the other side, we have 12 which can be taken common from the numerator and 4 again from the denominator. Now 4 cancels 12 3 times. Now in the numerator we have 1 plus d, and in the denominator we have 3 plus d. Now we cross multiply to get 3 plus d whole square, which is equal to 9 times of, that is 3 into 3 times of 1 plus d. Now further we expand this as a square plus b square plus 2ab, and then on the other side we just multiply. We bring all the terms over to the left hand side, cancel off the terms which are common like 9, right? And then further form a quadratic equation, but this is a quadratic equation which doesn't have a constant term, so it becomes pretty simple. As d is only taken common outside, the times of d minus 3 will become the monomial, thus it stands to be factorized. Now we apply the zero product rule, that is the product of these two numbers is equal to 0, that is a and b equal to 0, then either a is going to be 0 or b will be equal to 0. So if d is equal to 0, the common difference will become equal to 0. So that is something which is not possible. So that's why we neglect this value and we bring in the other, which is d minus 3 to be equal to 0, which gives us the common difference d to be equal to 3. Now when d is equal to 3, what we do next is we now talk about the value of r, as we remember that t3 upon t2 is equal to t2 upon t1 is equal to r. Right? So keeping the value of d, we can just talk about the first ratio, which was simplest, that is 3 plus d divided by 3 to be equal to r, right? So we write that, we keep the value of d to be 3, so 3 plus 3 becomes 2 times of 3, or it can just be written as 6. 3 cancels 6 2 times, as such we have the common ratio to be equal to 2. So this is all that is there in the sum. I hope you people must have understood this and enjoyed what an arithmetic progression and what a geometric progression is, and will definitely be able to find out the nth term of an arithmetic progression as well as a geometric progression. Well, I've tried to clear your concept. Now this is your turn to write a comment as to how you did like the lecture and share it with your friends so that I can help a million children. Right, that is my dream, and obviously to make a million teachers of mathematics, that is my larger dream. And you can be an awesome student of mathematics, might be if you cling and learn all that I have to teach you people, you can become a stupendous teacher of mathematics tomorrow. Make that your goal, and I'm sure you're going to do it. You will change the world. Now, if you have any problem in any topic that you want to clear, there is a Google form. Please fill it. Tell me what your problem is, and I'll come live and help you out. Bye. Have a nice journey of mathematics. A nice, joyous journey. Bye.